young mathematicians. Welcome to Summer School Grade 6, Week 4. My name is Alyssa Howell and I am the Director of Secondary Mathematics. Let's get started. This week, one of the I can statements that we're focusing on revolves around box and whisker plots, or box plots. By the end of this activity, we want you to be able to say two things. I can represent data using a box and whisker plot, and I can make comparisons between data sets using medians, IQR, which stands for interquartile range, and range. This activity is from Grade 6, Week 4, Day 4 of the summer school curriculum. In the activity, comparing data displayed in box plots, there is a problem that we have several questions that we need to answer about. Let's read the problem together. The owner of a blueberry farm recorded the following number of gallons of berries picked over 11 days, and you see the data given there. The problem asks us to construct two box plots. One box plot should contain outlier data points, and one box plot should not contain the outlier data points. So the first box plot we're going to do should have the outlier in it. But I'm not even sure that I know what the outlier is. Maybe if I put the data in order, that I'll be able to see which number is the outlier. Let's do that very quickly. So we're going to put the berries in the order, and I have 6, 26, 27, 28, 29, 30, 32, 36, 38, 40, and 42. I have to make sure that I have the same data points from before. Oh, I had 11 numbers before. I have 11 numbers afterwards, and I think I put them in order right. So our data looks like this. And I'm thinking that 6 is the outlier, but I want to do a visual check. And we can always do that by graphing the data like a dot plot. Dot plots make finding the outliers really easy. So I put out a number line, and then I plot each of my data points on the number line. And sure enough, all of the data points are pretty close together, except 6 to 26. That's a huge gap between those two data points. So that's how I know that 6 is the outlier for this data. And I also want to make a point right here. If I graph this data like a dot plot, this isn't very helpful. I just have a bunch of points along a number line. That's why a dot plot is not a good representation for this particular data set. And that's why we're going to make a box plot. So let's get started. And remember, in box plot number 1, we're going to include the 6, the outlier. When I find the median, I have a special way that I do this. I start at my outer 2 points, and then I move in each set just a little bit more until I can figure out what is the one number that's in the exact middle of the data. That's what the median is. It is the middle number in the data set. For our data set, we find that it's 30. There are other ways to calculate the median, but this is the way that I think is easiest. So this is what I chose to do. So now we have our data ordered, and we know that our median is 30. Once we have the median is 30, we need to find quartile 1, or Q1, and we need to find quartile 3, Q3. Since the median cuts the data in half, we see that there's an upper half of the data and a lower half of the data. Notice that the upper half is to the right of the median, and the lower half is to the left of the median. When we find quartile 1 and quartile 3, we find the median of each half. So we repeat our process for each half of the data separately. So remember, I like to use the process of finding partners from the outside in. And so as I move in, I find that 27 is quartile 1 and 38 is quartile 3. So now I can start placing my data onto a number line and create the box plot. I take quartile 1, my 27, and I place a segment there. I also place a segment at my median of 30, and I place a segment at 38 for quartile 3. I connect the quartile measures to create a box. Remember, this is called a box plot or a box and whisker graph. So we make our box and we put out our whiskers. We find where our whiskers extend by taking the very lowest point, which is 6, and the very highest point, which is 42, and I place line segments at those points on the graph, at the 6 and at the 42. And then finally, I connect with whiskers to the box. So this is our box plot for the data that includes the outlier, the 6. Now, we're going to make box plot number 2, but this time they don't want us to use the outlier. So our data now looks like this. It starts at 26 and extends all the way up to 42. We're going to start our process again to make a second box and whisker plot, and we follow the same steps. So, to find our median, remember my trick? I move with the partners in. So I'm going to wait 3 seconds to see if you can do that. Let me let you try that on your own. Do our partner sets, moving in to find the median. You have 3 seconds. How'd you do? Let's see what I was able to do. I start working my way in, each little set. Oh no! There's no middle number! What are we gonna do? I bet you know, don't you? You already know. When we don't have an actual median value because there's an even number of data points, we have to find the average or the mean of those two most central values. So we've got to find out what's in the middle, the median, of 30 and 32. So we add them up and divide by 2. When we add them up and divide by 2, we find out that 31 is our median for this data set. We have our median, and remember, that divides it into an upper half and a lower half. And do you remember what we do with those halves of data? That's right. We find the medians for each of those halves. So again, using the partner numbers, working my way to the inside, I find that 28 is Q1 and 38 is Q3. So I have my information. 28, 31, 38. Kind of sounds like a football play, doesn't it? And we're going to use those numbers to create our second box plot now. So I graph my quartiles. I create my box. I put my lowest number 26 and my highest number 42, and I draw my whiskers. Now I have box plot number 2 without the outlier. Now we can compare box plot 1 with box plot 2. Let's do that. The first question asks, how does the outlier affect the IQR? Now the IQR is a special value that takes the distance between Q1 and Q3. We can see for box plot 1, the IQR ranges from 38 to 27, And when I take that difference, I get 11. For Boxplot 2, I have 38 to 28. Those are my Q3 and my Q1. And I find that the difference is 10. So when I compare those distances, and the question asks, how does the outlier affect the IQR? It doesn't seem to affect it very much. It does make a difference, but it's not a very big difference. Let's look at the next question. Which is affected more, the range or the IQR? Now, we've already calculated the IQR values from the last question. Remember, that was Q3 minus Q1 to calculate IQR. To find my range, I'm looking to see how far it is from one whisker to the other whisker. The very, very highest and lowest values are what calculate my ranges. So for Boxplot 1, my range extends from 42 all the way down to the 6. That's a difference of 36. For Boxplot 2, the range is from 42 to 26, and that difference is only 16. So when the question is asked, which is affected more, the range or the interquartile range by the outlier, it's clear. The range gets impacted way more than the IQR. Remember that the IQRs didn't differ very much, but here the ranges are very different. Thank you for joining us this week. I hope you've had a great summer school experience. We've enjoyed learning along with you. Now I'll send the 7th graders to Jonathan.
Hi, I'm Jonathan Denning, Teacher Development Specialist at Houston Independent School District. For today's portion of HISD at Home, Math, Grade 7, we'll be working through Lesson 4 in Week 4. We hope by now you're at your goal of better studying patterns to be able to solve real-world math problems. Today is about helping you solve your math faster, more powerfully, and in fewer steps. You're ready for this. Let's get started. Our goal today is to solve, simplify, and substitute in real-world situations for volume and surface area. There's 3 steps you and I will take together today. We'll identify the shape, figure out which formula to use, and then substitute to solve.
Today's learning target is to solve, simplify, and substitute to find volume and surface area in real-world scenarios. Take the slice of cake here with the dimensions 4, 5, and a height of 6. Volume is the area of the base times the height. Notice the base is in orange. It's a triangle. This is a triangular prism. The surface area means we will take each individual side and add up the areas. We have 2 triangles and we have 3 rectangles. To compute the final surface area, we'll substitute our values into the equation and simplify. Your guiding question is, how is a formula used to calculate volume and surface area? Well, consider volume is how much an object can contain, what can fit on the inside, whereas surface area is what can fit on the outside, or how much it takes to contain an object. So as we go around the outside, how much area are we using? Now let's review. Volume, surface area. Remember, volume is the area of the base times the height. So as the height increases, what happens to the volume? It increases too. So the area of the base here is a circle, and we'll multiply that by the height. Now let's think about surface area. We're going to add together all of the different areas of each side. There will be 2 sides of this rectangular prism that are orange arrows. base times height. There will also be 4 sides that will be in blue, base times height. Now it's time for a quick quiz. The stones inside of the bowl, are they volume or are they surface area? That's right, they're volume. Our first example is exactly how much cleaning solution can the jewelry counter hold. So let's write out what we know from our formulas. We know that we're looking for volume. So we're going to write our first formula, which is volume equals the area of the base multiplied by the height. You'll notice our base here is a triangle. So when we write the area of the base, we need to remember that the area of a triangle is base times height divided by 2. So let's use a blue stone for volume, and let's multiply a large orange bird for the base by a blue bird for the height. So 3 times 4 divided by 2 is going to be 12 divided by 2. And 12 divided by 2 equals to 6. The last step you want to take is noting that you're going to multiply by your height, which is also 6. So if your volume is base times height, you're going to write volume equals 6 times 6, which is 36. Let's prove our solution. Let's say that the volume in the blue stone is equal to 36 inches cubed. Well, how did we get that? We know that this 36 came from our area of the base, and then we multiplied that by the height. Because we know that 6 times 6 is the base and height, we can put those and substitute those back into our formula. Now let's write our final answer. The volume of the triangular prism jewelry counter is exactly 36 inches cubed. Now let's dive in to example number 2. Same jewelry counter, exactly how much bubble wrap would you need to cover that counter? Well, remember the surface area is the combined total area of each of the sides of the object. So we'll need to know not only the area, but also how many sides and the lengths. So we can see that there are maybe 2 triangles, and we'll use 2 small orange birds for those. And I see 3 rectangles, but it looks like the legs are different lengths. So I'm going to use different size stones for those. If I add them all together and I substitute, I should have a total surface area. Well, let's draw a map. Let's say I have the 3 rectangles and then the 2 triangles. We'll make our triangles orange, and we'll start to fill in both the base of the triangle, which is 3. The length of the leg is 4, which means the last leg is 5. This triangle is a 3, 4, 5 triangle, and the height is 6. Now that our map is complete, let's take and substitute our length of our legs into our formula. We have 2 triangles and 3 rectangles. So the surface area of just the triangle should be both base times height divided by 2. So we'll fill in 3 times 4 divided by 2, which is 6, and 6 plus 6 is 12. Now let's try the surface area of the three rectangles, length times width. We have 6 times 3, 6 times 4, and 6 times 5. All together, we have 12, the area of the triangles, plus 72, the total area of the rectangles. Let's prove it out. 84 inches squared is 12, the area of both orange triangles, plus 72, the area of the blue rectangles. And the area of the triangles were base times height divided by 2, and the rectangles were length times width. Our final answer should say the surface area needed is 84 inches squared of total bubble wrap. This will ensure that every surface of the jewelry counter is covered completely. Now it's time for your 7th grade math course recap. Remember back to week 1 and week 2, we were working on integer operations, adding, subtracting, multiplying, and dividing. In week 2, proportions. Look to the upper half of this map for those types of examples. In week 3 and week 4, we were working on equations and inequalities, and volume and surface area. Look to the bottom half of the map for those examples.
We've reached the end. I hope you know that it means a lot to me that you stuck it out all the way to the end. Your perseverance and persistence are among the many fruits of the math labor that will serve you well in next year. Good luck, and we'll see you soon.
Welcome, young mathematicians. My name is Mrs. Lord, and I'm very excited that you're with us today. I hope you enjoyed the lessons from Mrs. Howell and Mr. Denning. Today, we'll be talking about surface area. Don't forget, you can access all of your summer school lessons through your teacher or through the HISD at Home website. Let's talk about surface area in the real world. Here's an example of a rectangular prism. You'll notice that the label has been printed on all 6 sides. So the company had to find the total surface area in order to figure out how much ink and the size of each label when they were printing. Here's another example. This is a cylinder, and you'll notice that this example shows both lateral surface area and total. So the company needed to know total surface area in order to determine how much tin to use for the can. But they needed to know lateral surface area when they were determining the size of the label. And if I can peel this off, we can see the size of the label. So here's our label. And it's lateral because you'll notice that it only goes around the side of this cylinder. So again, it's total when we think about the amount of tin needed for the can, but when the company was considering the size of their label, then they had to calculate lateral surface area. So let's talk about calculating surface area. In 7th grade, you learned that you could take the net of each figure, find the area of each shape, and add them up. In 8th grade, you learned that there was a formula. What's neat about the formula is that it works for both prisms and cylinders. So the formula is that the surface area equals, and we'll do the total, 2 area of the bases, or 2 times the area of the base, plus the perimeter of the base times the height of the figure, whether that's the prism or the cylinder. And I'd like to remind you that this height means the distance between the 2 bases. Now, if you are only asked to find the lateral surface area, you're only looking at the side, well, it's part of this formula. It's just this part right here. It's the perimeter of our base times the height of the figure. We're going to work with some of our real life examples to find the lateral surface area and the total surface area. You'll notice that the B and the P in my formula are capitalized. That indicates that these variables are talking about the base of my figure. This is the area of my base, or base area, and this is the perimeter of my base. For our first example, let's find the total surface area of this light bulb box. In order to do that, we're going to need to measure the length, width, and height. So let's start. We're going to use centimeters, and when I measure the length, you can see it's just a hair bigger than 6 centimeters, so I'm going to round to 6. So our length is 6. Our width is also 6. And our height is right at 11. All right. In order to move through these calculations, we need to always start by writing our formula. So our formula for our total surface area is 2 times the base area plus the perimeter of the base times the height. Now the next thing I'm going to do is I'm going to expand this formula by specifying what formulas I'm going to use to find the base area and the perimeter of the base. So let's do that. So 2. Now the base area, the base is a square, and I find the area of a square by multiplying the length times the width, or side by side. So 2 times length times width, plus, to find the perimeter, I would simply add the length plus the width plus the length plus the width, or I could simplify that by saying 2 times the length plus 2 times the width, and then finally times the height, which is the distance between the two bases. Now I'm going to substitute in for my variables. So the surface area is going to be 2 times 6. The length is 6, the width is 6, 6 times 6, plus 2 times the length, plus 2 times the width, times the height of my prism. All right, according to PEMDAS, I'm going to start with my parentheses. 2 times 6 is 36, plus 2 times 6 is 12. 2 times 6 is 12, and I know that 12 plus 12 is 24 times 11. So total surface area is 2 times 36, which is 72. 72, plus 24 times 11, which is 264. And finally, I'll add these together for 336. What did I measure in? I measured in centimeters, and since we're finding area, which is 2-dimensional, I need to say squared. So my final answer is 336 centimeters squared. If I had been asked to find the lateral surface area, just the sides, remember I would only use this part of the formula. The lateral surface area is the perimeter of the base times the height. So it would be this second part of the formula, and I can go ahead and say that the lateral surface area is 264 centimeters squared. For our second example, let's take a look at this olive can, and I'm going to find the surface area of this label. So I'm going to find the lateral surface area, which means I only need this part of the formula, the perimeter of the base times the height. So again, just like last time, let's go ahead and get our measurements. I'm going to use centimeters, and you'll notice that it's right at 6.5. There's 6, there's 6.5. So this measurement is our diameter. And the reason I'm finding our diameter is because, well, I'll tell you in just a minute. So our diameter is going to be 6 5/10, or 6.5. And we'll need the height of our cylinder. So when I measure that, you'll notice it's right at 5. So our height equals 5. All right. Now, just like last time, we're going to go ahead and start by writing our formula. So the lateral surface area is going to be the perimeter of the base times the height. Now remember, last time we expanded this formula by inserting the formula that we'll need in order to find the perimeter. So if you remember, the perimeter of a circle is also called circumference. So let's go ahead and write in the formula for circumference, which is either 2 pi r or pi d. I'm going to use pi d because I know my diameter. So pi times our diameter times the height of my cylinder. All right, let's substitute our numbers in. So pi times 6 5/10 times 5. And now I'm going to use my calculator, and my lateral surface area turns out to be 102 1/10 centimeters squared. And that's it. I could not be more proud of how hard you have worked these last 4 weeks. I hope you feel the same way about all of the work you've done. Have a great rest of the summer.